Hello everyone, welcome back. In today's video, we would like to write a program to find the remainder of a division. In order to review, when we want to divide 10 by 2, 10 is our numerator and 2 is our denominator. Okay, so we are asking the user to enter a numerator and we are storing it in variable x, for example. Let's say I name it x. And then I am asking the user to enter the denominator, and whatever the user is going to enter is going to store in a variable called y. Okay, so a numerator is asked from the user, which is stored in x. A denominator is asked from the user, and it is stored in y. Then, in order to find the remainder, I need to use the math library and fmod function. So this is my fmod function. And to access that, I need to type down math.fmod. And in parentheses, I need to put two arguments, one before comma and one after comma. So the one that is before comma, I need to put my numerator. And my numerator is stored in variable x as you see it here. So I type down x, and then after comma, I need to type down my denominator, which is stored in variable y. And we can name it whatever we want. We can name it h, we can name it r. It depends on what we want, okay? Then this fmod function from the math library is going to calculate the remainder of the division of my numerator divided by denominator, and we are going to use the print function to print our remainder in the output. So when I run this code, it says enter the numerator here. Okay, so I want to divide 10 by 2, for example. 10 is my numerator and my denominator is 2. It says the remainder of 10 divided by 2 is 0. Yes, okay. So if I type down my numerator to be 11 and my denominator to be 2, now we see the remainder of 11 divided by 2 is 1. So using the fmod function from the math library, we can easily find the remainder of a division. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates the total number of pages required to print a given number of lines, where each page can hold a fixed number of lines. Here, we are using the math library. We are asking the user enter the total number of lines to print. It is assigned to lines variable. Then we ask the enter the number of lines per page, and it is going to be assigned to lines per page variable. Then we are going to divide line by lines per page. Okay, and then it is going to be assigned in pages variable, but we want to round it up. In order to round it up, I use the actually math library, and I also use or call the ceil function from the math library, and in parentheses I type down lines and then lines per page. For example, if I have, for example, 200 lines, and in each page there are 19 lines, so I would like to know how many pages do I need. So 200 is divided by 19. The result, if you do it yourself, will be approximately 10.52, but because we are using the ceil function, the output will be 11, so it is rounding it up. So let me run the code. It says enter the total number of lines to print. So the total number of lines, it's 200, for example. Then enter the number of lines per page. I would say it's 19, for example. It says you will need 11 pages to print 200 lines. But you see that 200 is divided by 19 in this formula here. 200 is divided by 19. But because we are using the ceil function, the output, which is 10.52, is rounded up to 11, and we see that in the output, number 11 is shown. So this is how we can use ceil function from the math library to round up the output for us. Thank you for watching.